Sorry. Hello guys, today we're going to react to this, whatever the hell this is supposed to be. Oh my god, what are you doing? No. Okay. There we go.
Hello, it's James here. Paramount have asked me to build a real transformer for the upcoming Bumblebee movie. It's going to be 4 meters long, 1.5 meters wide, and transform into Bumblebee that'll be over 3 meters tall. So I can build all the mechanics. This is a pretty big project, so I'm going to need some help.
Hi, James.
This is Kyla, who's the prop builder.
Oh, you need help?
If you're going to make the mechanics, then I'll make the external panels and cosmetics using various materials, so it looks really good.
Wait, we've got to build the whole thing? We better design it.
How are you thinking properly? Get on the job. They're making a transformer. What thing? The little dot thing? Yeah.
The chassis for this has got to be pretty strong because it's got to hold the whole weight of a transformer, so I'm making it out of box section steel. My welding's not that good, so I'm putting some metal brackets on. I'm pre-drilling all the holes so I don't have to do them afterwards. They've got paint on those, so I probably need to grind all of that off. Yep, still doing stick welding. I'm learning as I go, but I'm still not that great, so I'm not going to show you my welds. Now, this is going to be quite a big machine, and plywood is stronger than steel, pound for a pound. It's also going to be pretty chunky, so it looks like a giant robot. So lots of this is made of laminated plywood.
Plywood is not even close to stronger than metal.
Yes, it is glued as well as screwed before everyone starts panicking, and you can see some of the big holes there that I've taken some big axles through.
I'm not even gonna ask why.
This piece that I'm making is going to make the main base for Bumblebee, so of course it needs to be painted silver to look like the internals of a giant robot.
But that would be gay, so I'm not going to.
So we're making a car, but what wheels are we going to put on it? Well, Beetle wheels are pretty big. They're about 2 foot in diameter, so I found these, which are wheelchair wheels. Now, they're designed to be supported from one side. They've got this handy rail on the outside where you push yourself along, which we're going to use to put the hubcap on. And these are super heavy-duty off-road ones, so hopefully they're strong enough to support the whole thing. Now, I've knocked the bearings out already, which did have a 12mm bore in, and now we've got about a 25mm hole that I can put a bigger axle in.
Now you need a real small hole for your axle.
I've got proper bearing blocks, the sort of thing you'd have on a go-kart, so they should be pretty strong, and of course those are bolted to the steel. So my wheels bolted on with lock nuts, there's a bearing block bolted to the steel, and the axle goes all the way through here to the other side. So we've got another bearing block that's recessed so that the axle's level, and that's cantilevered against the one mounted on the steel. But will the wheelchair wheels be strong enough to hold a whole transformer? It looks like they are.
No,
yep, I can't see the spokes buckling, so that's good. So these are the transformer's ankles, so now we just need to build the next bit that hinges on these pivot points. That's right, there's loads more lovely plywood laminated together and painted silver. Yeah, these parts are more than strong enough for the project, and obviously much lighter than steel or some metal, and we can make them nice and chunky so they look like bits of a robot. So down here we've got these big bearing blocks to 20mm axles for the pieces that pivot through the wood here, and some of them are fixed, and the pivot and the bearing is going to be on the piece of leg. So let's get all of that stuff assembled. Underneath the bottom here, we've got the bottom of 2 pneumatic cylinders that are going to push the legs up, and they're on a steel tube with some nice end caps on.
Stop playing.
Right, here's one leg together. Just got to do the other one, and we'll put some air in it. The mechanism of the legs is a bit like a weirdly angled scissor lift, and that means I only need one pneumatic cylinder in each leg, and that will bring the body up eventually to exactly the right angle.
Okay.
so both legs are together. We've got a few more plates and stuff to hold some of these pieces together so they're locked together, but on the whole it's looking pretty robust. And we've got lots of metal in there and bearings. There's some 3D printed bearing blocks, but we can always upgrade those if they're not strong enough. I think they're going to be fine. Right, let's put some air in it and see what happens. Up they go, and let's see how strong that is. And the hoses aren't very good. No, it's come off. Yeah, got a lot of leaky hoses, but hopefully that's going to be strong enough.
You got that right, Anthony.
What?
Oh, never mind. It is strong enough. It's holding a whole man, not. I can see the rope.
But wait a minute, we've got to make an entire prop car as well, and that's why Kyla's here. So she's cutting all the templates out of foam, having spent quite a few days making them.
Cool. Why is she using black foam? I feel like you should use white foam.
Our car, of course, needs to have windows as well, but we don't want people to look inside and see the Transformer before it's time, so we're using tinted acrylic.
Think of it, when you're painting it over black, it's not gonna work that well. And I'm not being racist. Do you want me to be racist? Honestly, I think Irish people are just straight up stupid. That's really nice.
What are you doing, Kyla?
I am drilling the hole out for the handle. Just doing it outside because it's very messy.
Not drilling. I'm using a hammer and a sanding bit.
What's that?
And I know that because I am
It's a
very
car door.
experienced with tools.
So we've got a whole door made of foam,
That's cool.
which looks good, and the handle. And what's on the back? So what have we got there?
So we needed to reinforce it. We could have done it using wood, but we decided to use insulation foam so that we could actually cut out slots to run the aluminium supports through.
So we've got some extrusion there that's going to mount it on the frame so it can be mechanical and open like a gull-wing door. So what's next?
Well, foam is a pretty porous material, so I'm going to have to seal it before I go on to painting it.
Yeah, we're using the proper good sealer here that's mixed with white spirit and absolutely stinks. You put on about 2 or 3 coats, but it does give you a really, really good finish.
Oh, there's blue now.
And of course Bumblebee's yellow, so we've used absolutely tins and tins of yellow paint to paint the entire car.
Alright, I guess that works.
The details are hand painted and the doors are a bit yellow and glary at the moment, but they're going to be dirtied down once we've done all of it so we can get a consistent look and feel over the whole car, and it looks like a dirty old Beetle that you'd find on a scrap heap, just like in the movie.
I like that window. That's nice and shiny. See, now that's what you use black colors for, right there.
Yep, it's back to me again, and more metal parts. Cutting through metal with an angle grinder is quite a satisfying experience because you feel like a real engineer making a real giant robot.
It's because that's exactly what you're doing. Being an engineer, making a giant robot.
It's another bit of welded steel, which is going to make Bumblebee's body, or the main hinge at least, at his hips where he lifts up. Whoa.
No transformer put on the real Transformers list. Not.
Right, so that's now the body piece that lifts up when the whole thing goes up. Whoa, it's getting pretty heavy, so that's going to make it really tall. So this gets pushed up by these bearings at the knees.
fucking go.
Now we've got these two steel rods, which are mounted on bearings at the knees and bearing blocks at the top, and those are going to push the body up, hopefully. It's a bit of a tight leverage angle, but we'll see how it goes.
What do you mean by hopefully?
Yep, that was pretty close. I kind of measured where the ceiling was, but that's a bit closer than I thought it would be. So Bumblebee's feet are going to be down here. These are his knees. Obviously, he's going to have cosmetic panels covering him, and then this is his waist, and his body, and his head's going to be up there about another metre. Right, that's the end of video part 1. Thanks again to Paramount for making it possible to build Bumblebee, the real Transformer. Next time, I'm going to be building more mechanics.
And I'm going to be building more cars.
Hello, it's James here. Paramount have asked me to build a life-size Transformer that turns from a car into Bumblebee. This is Kyla, who's a prop builder, who's come to build some of the cosmetic parts like the car and Transformer parts. Last time we built quite a lot of the mechanical assembly, and we also made these car doors. But we've got quite a lot of work to do, so we better get on with it. It's time to do the next section, which is the big piece that goes like this, and I think it's going to lift it up in one stage and then lift everything up on the other pneumatic stage. So we've got a piece to make and another pneumatic cylinder that fits in here. So all the pieces fit in the CNC machine for this. Last time they were too big, so I had to make them by hand. But now we've got down to the more detailed stuff. That means we can cut it out automatically. So this is our piece that moves, and we've got our front forks here, which is where the front wheels and wings rotate. Boop, boop, boop. So attached to the bit of Bumblebee's body we did last time, we've got two panels like this, which fit on here. And these are going to be detachable because it won't fit under the ceiling and I won't be able to test it. And on there's that other pivot piece that lifts all the way over.
I didn't get why I won't just assemble it outside. It would make more sense.
Right, I've got another cylinder here now, which is responsible for this stage that pulls the top of the car over before it stands up. Just need to put some end stops in this direction between these bars, because at the moment that cylinder's resting on the axle, which isn't too good for it, but I should have enough power. Well, I hope everyone's happy with a mechanical elephant instead of a transformer. So this pivot point here is where the whole of the front of the wings and the wheels pivot as it stands up. So we need to build all of that onto here, and that makes the front of the car, and the wheel centres are about this far further ahead. So this piece rotates round and that holds the front wheels, and the front wings also slide on this V-slot. Right, this is one of my upper arm pivot points. We're going to put some 20mm studding in there that runs all the way down, and this fits on here, and there's one on the other side, and that makes the shoulder pivot. So this is part of my gull wing door assembly, and so are these on each side, which is where the pivot is for the gull wing. So we're going to have a piece like this, which has got this lovely shape on. So this gets pulled by a pulley into the mechanism down below as it transforms, and that should pull the doors up. Right, I've got some bits of 2020 extrusion with 3D printed joints on, which we're going to use to make the next bit of the frame, which is articulated. So here's that bit of frame, which hinges like so to lift the back away so that the front can lift up. And that's going to be something like the second or third stage of the transformation. So we just need to put the other side on and link the two together so it's not really wobbly.
Oh, this is what I
Right, so that's the framework for the back of the car, all the way down to the boot here, and this piece now hinges all the way back, and it should miss the back entirely, and that's the stage that happens before the other stage comes up onto the top and the doors go wing. Right, we've got the frame in the back, so Kyle is using that to fit the foam panels too. We've got a couple of pins in there to try and position the foam, and then that's going to make the boot shape. Right, we've got some 3D printed parts which are going to make up the arm joints, and they're all attached together with 2020 extrusion, and that should make up the shoulder and the elbow where the arms fold out. So the arms mounted on the arm pivot points we put on earlier. This is the elbow, so this is going to swing out round here, and then the elbow will eventually come down when the robot stands up. So this is the inside of the arm on the front, and the outside here is on the back of the arm. So we've got lots of space for cosmetics between these two, but not so much on the outside. So you'll notice there's a pulley here, and there's another pulley here, and we can mount a motor on each stage, which will allow the arms to operate. Right, we're around the front of the car again, so as well as this swivelling over as Transformer stands up, we need to make a thing that makes the wings slide in and out. So they need to get narrower, so that they basically make Bumblebee's chest. So I've got these sliding things with little V-wheels on there. We've got one on the top and one on the bottom. We need to link those together, and then we need to motion link that so the wheel also pivots outwards as the wings slide inwards. So I need to link these two things together, stick them on, and try and build the rest of the mechanism. So we've got two of them now that slide, and now we need to do a mechanical linkage to swivel the wheels out. Right, so now we've got this piece here, which is the new wheel centre, so that will go on here, and we've got a template for that wheel to be made, which is part of the frame, so that's going to be sort of a fake front wheel that sits there. And then as this slides out, this thing has to slide in, so we've got that sort of motion, which shouldn't be too hard to work out, because that can pull this in on a lever. But that has to happen as the whole thing rotates round, so that's going to be a bit harder to do, but hopefully we can do it all with one motor. So now I've added another linkage here, which is a crank, so as this moves, it pulls in this part, and that seems to rotate quite nicely. And all these legs are adjustable. Obviously I can slide these up on the 2020, and this is a piece of studding, so I can adjust all the leverage angles, but that seems pretty well in the right place to get that wheel pivot flat and to get the wing right out, and when the wing's in, this goes back to roughly the right angle. Right, we've had to relocate everything to a mysterious Silver Line space-age location, because the machine is now too big to fit in the house.
Talk about
We're getting there with the body panels. The only piece of the car that's not part of the transformation is the bonnet, which has to be ejected and thrown away, and that's because it's absolutely huge and there's nowhere to put it. In the movie, it looks like it folds up into about 8 pieces and magically disappears into Bumblebee's chest, but that's going to be a bit tricky to do. So we're going to make a bonnet ejector. So we're going to make some sliding rails out of a piece of 2020 extrusion, a piece of box section which handily fits on the 2020 extrusion. We're going to have 2 of those mounted on the front forks here, angled up slightly so the bonnet sits down on them, and then we'll have some sort of pneumatic air cannon that pushes the bonnet off like that and ejects it. There'll be more on that next time. So it looks like we've made a car. We've got a few more panels to do and quite a lot more painting to do, and we're going to dirty it all down so it looks like a beetle found on a scrap heap, just like in the movie. Well, that happened at the end, so we get a consistent look and feel. But that's all for now. So next time I'll be doing loads of electronics, putting motors in and doing loads of plumbing.
And I'll be making transformer parts.
So thanks to Paramount for making it. Hello, it's James here. This is part 3. Paramount have asked me to make a transformer that turns from a car into Bumblebee. Last time I did a lot of the mechanics. This is Kyla, who's a prop builder.
So this time I'll be continuing with the cosmetics, including Bumblebee's head and his arms.
Yeah.
And I'm going to be finishing the mechanics and doing lots of electronics and control. So it looks like a car, so that's good, isn't it? But I've had to make a couple of mechanical changes to do with the transformation since last time due to power and things like that. To pull all the pieces up, now we've got the cosmetics on. So let's have a look at that. The main difference is there's now 2 pneumatic cylinders in the back of the car here that are responsible for pulling the front of the car up before the transformer stands up. And that's because I found we just didn't have enough power with the single cylinder that I had. Now we've put all the cosmetics on things on the front. I've also positioned them so they're much higher, so the leverage angle is better, so higher at the back and much higher at the front. It was seated much further down before, and that's allowed the thing to work essentially. But it also has meant that the pulley that pulled the gull-wing doors up doesn't fit anymore, so we've got another plan for that. So the gull-wing doors are now operated by these electric actuators, so they can operate independently from the stage that pulls the front of the car back. That also means I can pop them out to get the arms up where I need to before we do the transformation. So let's have a look and see what it does so far. So far so good. Well, it's a bit back heavy, so we need to do something about that. Maybe some casters that stick out the back. For now, we sort of got to try and tip it back again. Don't know how I'm going to do that, so there we go. So what's the analysis?
Well, it works, but it's really back heavy.
It is a bit, so I'm going to put some bars in that extend the chassis to stop it tipping over with some blocks on, and I'm also going to put a brake in, which is actually there, but looks like it's in the wrong place, to stop it tipping so far over that it tips over backwards. It's time to build some control electronics for the whole thing, so it's going to be Arduino based, but we're going to have 2 remotes, one for driving it when it's a car that looks like this, and another one with an Arduino in it and a Bluetooth connection, and 2 3-axis joysticks for controlling it when it's a robot. So its main brain is going to be an Arduino Mega 2650 with half a Bluetooth link on that receives from the remote, and that's going to control everything. So then we've got some relay boards which are going to control the linear actuators, because those have got their own end switches, and they're also going to control the solenoids for the pneumatic valves. Then we've got some proper motor drivers we can feed with PWM and get feedback pops on the joints to control the arms. And the head's going to be controlled by servos off the same Arduino. So inside Bumblebee's remote is another Arduino and another Bluetooth link, and if I power up this one, they should pair together. So after a few seconds, we should see that it's waiting to pair, and now it's paired. And we've got this counter here, which is actually running on the remote Arduino, sending the data back, because of course it's a transparent serial link, so we can have 2-way data communication. So that counter is showing me that the code is still running, and it hasn't hung or anything nasty like that. And the mode, of course, is also kept on here, so these buttons will increment the mode or decrement the mode, and those are going to be the stages of transformation. So basically I will go upper mode, try the first part of the transformation by pressing the blue button, which will execute some function on these relays or whatever it is, or make the arms move, or whichever stage I'm at, and I can actually see whether it's worked before I proceed to the next one. Of course, then I'll go upper mode and we'll do the next piece of the transformation all the way up. When we've got to a certain point, these joysticks will make the arms and the head move, and then when we're ready to transform down, we keep going up and executing the modes, checking each one for safety reasons that it's completed before we continue. So moving on a little bit, we've mounted our Arduino, the relay board for the front, which operates some of the pneumatic cylinders, and the back canopy of the car. We've got a little voltage monitor thing there and power distribution for 12 volts, and I've got my menu now, so it operates, so now I can scroll up for all the stages of transformation, bonnet eject, putting the back canopy back, coming up to putting the doors up, all the way through till we go and put the front pneumatics up. And now if I press select, you should hear that activating one of these pneumatic valves, and that relay is on. The next one is standing up, which activates another pneumatic valve, and that one's going to let air into those cylinders in the legs, but it won't let it out until this one activates. So that's right down in the next stage of transformation, to transform back into a car. So that now activates that cylinder and lets the air out. And we've got all these stages through on the menu, so I need to fit this in the back of the car and run wires out to the arms and wires out to the other relay board that operates the gull-wing doors, the bonnet ejector and all the stuff at the front. But what's in the boot?
Or you could just say...
Yes, it's all the electronics. We've got one relay board, a power distribution thing, and the Arduino that's paired to my handset. And on the other side, we've got a nightmare of pneumatic plumbing, including this flow restrictor, which makes it come down slowly. Let's talk about the arm motors. So we've got these lovely motors with gear heads on, and I 3D printed big pulleys that are going to drive cables that go around the big pulleys on the arm joints that we looked at last time. And we've got a number of feedback pots. So these are 10-turn pots, which can be coupled straight to the pulley on the motor, and that can give us the position, so we can drive those proportionally with feedback, and we can use PID controllers to position the arms. We've got 2 motor drivers mounted on the top of each arm, and that's going to allow us to do proportional control. So we've got PWM drivers from the Arduino in the back, and also we've got the wires there for the analog pots. And floating around in the top of the car, we've got the other relay board that operates the gull-wing doors and all the stuff at the front. So under the bonnet, we've now got this cunning pulley system and some bungee that pulls the sides in. So if you remember, these slide in and the wheels slide out, and now there's a pulley on a string, and that goes all the way around, and it goes around here, and that means when this rotates, it allows this to slide in and the wheel to slide out to make Bumblebee's shoulders. Then up here, we've got a linear actuator that pulls this strap, and it pulls all the way around the pulley, and that pulls the front round, and that same rotation axis, of course, unwinds the string and causes these 2 stages to work.
Here I am making Bumblebee's head. I traced the templates onto a slightly more flexible foam than what we've used for the car panels. It should make forming the complex curves of the head a little easier. After sanding all the seams flush, I applied a couple of coats of sealer to the foam before spray painting the head the same yellow as the car. As with the details on the car, all the black and silver areas were painted by hand.
So what's this?
It's Bumblebee's head.
He's got lights in his eyes, just like in the movie.
And now I've got the rest of the parts to make as well.
So what's next?
Well, this is one of his arms. We've had to be really clever when it comes to designing the cosmetics for Bumblebee, because everything has to fit down as small as possible so it can get in the car.
Well, we're in England and it's winter, so it's raining. So I've got my tent up on stilts so I can do some tests of the robot. So those leg cylinders seem strong enough to take it all the way up with no problems. I'm only using about 60 psi, which is about 4 bar. I've still got to sort out the wobble of the front wheel arches, which need firming up a bit, but my anti-roll measures seem to work, and the front forks rotate round and all of that stuff transforms as well. Coming down's not quite so clean, there's a bit of work to do there, but it's looking pretty good. The whole thing's got to drive along as a car, and it's going to be radio controlled, so somehow we need to power the wheels. I'm going to do that using this. So we've got a NinjaFlex 3D printed roller with a rigid core and a T5 pulley 3D printed into it, and inside each end is some 8mm skate bearings, and that's running on 8mm studding attached to this steel. Then we're going to use this good old brushless motor that I've used in loads of other vehicle projects with a belt drive there to there, and that's going to drive this roller, and that's going to rest on the back wheel. So we've got a pair of those, and we've got the belts on, those are nice and tight, and we've got a belt tensioner on the bottom, which is some zip ties between 2 bolts. So we've got one of those fitted to each wheel each side. The little wheel runs on the actual wheel, and that seems to work pretty well. Not sure how fast it's going to go, but there should be plenty of power, and of course if I drive one faster than the other, it'll turn and it'll run on the casters at the front. So it looks like my wheel's spinning off centre. I wonder if the axle's bent under the load. But seems to be running all right, and we've got braking, so That should hold it in place as well. Oh, yeah, that's pretty strong. So I think it's going to be strong enough to power it along. We have got a tensioner at the back here, which is bolted through the steel chassis. So it should be okay to add more tension that pulls this round to the bigger radius of the wheel. In the bottom of Bumblebee's head, we've got a plywood frame with a 3D printed piece across with a hole in, and that makes a pivot so his head can turn. On there's another pivot, which means his head can move backwards and forwards, so he's got 2 degrees of freedom. And to make that move, we've got these 2 pegs in the back of his head now, which we're going to push around with servos. Bumblebee's head's mounted under the bonnet, and we've got 2 servos that move the head around. So now when I twist these controls, first of all we're going to operational mode. That brings his head alive. When I twist these controls, one operates each servo that gives me that range of motion. I can't push forward too much because the ground's there. Obviously it'll be stood up, it'll be able to look forward down at you from its 3-metre height. If I twist them both, then it brings the head back. And of course we can look left and right as well by doing this sort of thing and give it quite a lot of good expression there. So I've got quite a lot of good animatronic control. I've got some motion filtering on the servos, but we can put more on. I think that'll probably do those, so we can make quite quick, abrupt actions to look at people. So let's have a look at the upper arm mechanics. So hopefully now you can see the motor fitted here with its feedback pot at the bottom and a cord that goes around the pulley on the upper arm. So if I put my transmitter into arms out mode, then it should bring the arm out when I press the button. There it goes, and that's the default pose which will be at when it's standing, which is arms about like that. Of course it's face down at the moment. If I scroll up into operational mode, then we should now have animatronic control with the stick on my remote, so I can move the arms around, and of course moving front and back will actually be the elbow, which isn't fitted yet, which goes on the bottom here, but that'll be the same, so I'll be able to use that stick to have animatronic control over the arms. If I scroll back up into going home mode, so where we're going to transform down, we can fold the arm back in, and the motor shuts off when I let go of the button, so it's not constantly sapping power. So each arm's actually got its own battery. We've got a battery on the roof, and we've got one in the boot as well, and that powers all of the electronics. And in the boot, we've got a 24-litre air tank that goes up to 120 psi. Yes, with a regulator, so we're going to turn it down significantly. That gives us consistent power about 60 psi till the actual cylinder goes less than that. But that's going to give us enough to do at least 1 transformation up and 1 transformation back. As I mentioned last time, we've got to eject the bonnet before we can transform, because in the movie it folds up into tiny pieces and it's absolutely massive, so we've got to get rid of it. So I'm going to use this to eject it. Yes, it's a drain plunger with some 3D printed attachments. So basically I've got a bungee now that pulls the top back down, and that's actually going to be locked in place, and that's going to hold the back of the bonnet. And then basically when we fill this with air, it's going to pop up, and then we've got so much air pressure that in fact it explodes and the top comes off completely. And hopefully that's going to cause a satisfying tumble of the bonnet. It's time to dirty down the Beetle and make it look like a dirty old car found on a scrap heap, just like in the movie. Kyla's using some acrylic paint, watered down, brushing it on and wiping it off, building up layers of dirt. Meanwhile, I thought I'd have a go with some clear lacquer as glue and actually throw dirt at it that I found in my garden. Yep, that's more earth from the garden. And some more paint. Well, I'm pretty sure it's looking like a car. And actually got some windscreen wipers, which are actually from a car. They're the smallest ones I could find, but fortunately they don't have to be functional. Alright, that's the last video in the build series, but that's not everything.
Come back next time to see everything together.
Thanks again to Paramount for making it possible to build a life-size Hello, it's James here. Paramount have asked me to build a life-size transformer that turns from a car into Bumblebee. This is Kyla, who's a prop builder, who's come to build some of the cosmetic parts like the car and transformer parts. Last time we built quite a lot of the mechanical assembly, and we also made these car doors. But we've got quite a lot of work to do, so we better get on with it. It's time to do the next section, which is the big piece that goes like this, and I think it's going to lift it up in one stage and then lift everything up on the other pneumatic stage. So we've got a piece to make and another pneumatic cylinder that fits in here. Hello, it's James here. This is part 3. Paramount have asked me to make a transformer that turns from a car into Bumblebee. Last time I did a lot of the mechanics. This is Kyla, who's a prop builder.
So this time I'll be continuing with the cosmetics, including Bumblebee's head and his arms.
And I'm going to be finishing the mechanics and doing